Hello students, here now we try to solve the exercise 2.1 in which we have to find out number of zeros of px. Zeros means the point of intersection of the curve on x-axis. Here this curve line is not intersecting this x-axis. This line is not intersecting this x-axis, hence number of zeros will be 0. Here in this one, this curve is intersecting x-axis at this point. This curve is intersecting the x-axis at this point, hence the number of zeros will be 1. Here in this curve is intersecting x-axis at this and this point. The curve is intersecting the x-axis at 2 points, hence the number of zeros are 2. If we look at this curve, it is intersecting x-axis at here, here and here. It is intersecting the x-axis at 3 points, hence the number of zeros are 3. Here in the exercise 2.2, we have to find out the zeros and verify the relationship between the zeros and the coefficients. We have 3 coefficients here. First is a, which is equal to 1. Coefficient of x square is always a, which is 1. Coefficient of x is always b, which is minus 2. And constant term is always c, which is minus 8. Coefficient of x square is a, coefficient of x is b, and constant term is c. Now we have to find the zeros of this x square minus 2x minus 8. It is a quadratic polynomial. To obtain zeros of this polynomial, we have to split the middle term. X square splitting of 8 so that we get minus 2. It is minus 4 to the 8. So 4 and 2 are factors. X square 4 into x minus minus plus 2x minus 8. Now take common from these two and these two. We have to take common from these two. X is common, x minus 4. Then from these two, 2 is common, x minus 4. One of the bracket is x minus 4, another is x plus 2. 4 zeros. We have to equate both of these factors by 0. X minus 4 equal to 0 and x plus 2 equal to 0. Here x equal to 4 and here x equal to minus 2. We consider these zeros as alpha and beta. Suppose this is alpha and this is beta. We'll consider both the zeros as alpha and beta. We can take any one of as alpha and other one as beta. Now the verification. Alpha plus beta equal to minus b by a, and alpha into beta equal to c by a. Here alpha is 4 plus beta is minus 2, b is minus 2, a is 1. 4 minus 2 is 2. It is minus minus plus, so it is equal to 2. Now alpha into beta. Alpha is 4, beta is minus 2, c is minus 8, a is 1. 4 into minus 2 is minus 8, is equal to minus 8. Hence verified. Now again listen. First of all, we have to split the middle term here. We are getting 2 factors. equate this factor with 0 and this factor also with 0, we are getting two values of x which are known as zeros. First zeros will be considered as alpha and second will be considered as beta. After that, we have to use the formula for the verification. Sum of the zeros equal to minus b by a. Sum of the zeros equal to minus b by a. We are putting here the values and verifying it. Product of the zeros equal to c by a. Then we are putting the values and verifying it. Now in this third part, this is quadratic polynomial given to us which is not in the standard form. So we have to rearrange it. First of all x square, then we require x. So write minus 7x and then minus 3. This is the rearrangement of the polynomial. Now we have to split the middle term here. 6x square. Now 6 into 3. 6 into 3 is 18. We have to make the splitting of 18 so that on subtracting we get 7, which is 9 and 2. 9 into 2 is 18 and when we subtract it we get 7. Here it is minus 9x minus 2x and minus 3. 6x square minus 9x and minus minus plus 2x minus 3. Take common from these two and these two. From these two, 3x is common. So here 2x minus 3. And here 1 common. So 2x minus 3. One of the bracket is 2x minus 3 and another is 3x plus 1. Now we have to equate these two with zeros. 2x minus 3 equal to 0. 3x plus 1 equal to 0. Shift this 3. 2x equal to 3. Here shift this 1. 3x equal to minus 1. X equal to 3 by 2 and x equal to minus 1 by 3. This is first zeros and this is second zeros. This will be considered as alpha and this will be considered as beta. Now this is our alpha and this is our beta. Here a is coefficient of x square. Coefficient of x square is a, which is 6. Coefficient of x is b. Coefficient of x is minus 7. It will be b. And the constant term is c. Now we do the verification. We have formula alpha plus beta equal to minus b by a and alpha into beta equal to c by a. Alpha is 3 by 2, beta is minus 1 by 3, b is minus 7 and a is 6. Alpha is 3 by 2, beta is minus 1 by 3, c is minus 3 and a is 6. Take the LCM of these two. 3 3s are 9 minus 2. Here it is 7 upon 6. 7 upon 6 equal to 7 upon 6. It is verified. Here when we multiply these two, minus 3 upon 6, which is equal to minus 3 upon 6. Hence, verified. Now in this fourth part, we have to find the zeros and then we have to verify for the coefficients. It is having only two terms. Our first term is with u square and second is with u. So there is no need to split the middle term. Take the common from these two terms. 4u is common. Here it is u plus 2. Now we have obtained the factors, so equate these two factors with 0. 4u equal to 0, u plus 2 equal to 0. Here we get u equal to 0 upon 4. Here we get u equal to, shift this on this side, minus 2. So u equal to 0 and u equal to minus 2. Let this be alpha and this be beta. A. Coefficient of u square. B. Coefficient of u. C. Constant term. We don't have constant term here, so it is 0. Now the verification. Alpha plus beta equal to minus b by a. Alpha into beta equal to c by a. Alpha is 0, beta is minus 2, b is minus 8, and a is 4. Alpha is 0, beta is minus 2, c is 0, and a is 4. 0 minus 2 is minus 2. When we divide these two, we get minus 2. Here 0 into minus 2 is 0. When we divide these two, we get 0. Hence verified. Now we have to find out zeros of this polynomial. In this polynomial, we are given with the quadratic form, then t is not given, then the constant term is given. Whenever you have such problem where the middle term is not given, you have to make the use of formula a square minus b square. T square is given, middle term t is not given, and then the constant is given. In such problem, you have to apply this for identity. It will be t whole square 15. 15 is a square of root 15. This 15 is a square of this number. Now a square minus b square. A plus b and a minus b. Equate these with 0. T plus root 15 equal to 0 and t minus root 15 equal to 0. Here t equal to, shift this, minus root 15. And here t equal to, shift this on this side, root 15. Now this will be considered as alpha and this will be considered as beta. A means coefficient of t square, which is 1. B means coefficient of t. We don't have t here, so 0. C means constant term, which is minus 15. Now the verification. Alpha plus beta equal to minus, alpha plus beta equal to minus b by a. And alpha into beta equal to c by a. Alpha is minus root 15. Beta is plus root 15 minus b. B is 0, a is 1. Alpha is minus root 15. Beta is plus root 15. C is minus 15 and a is 1. This is 0 equals to 0. Here it is minus 15 equals to minus 15. Hence verified.